So today we're going to be talking about combining radicals. And just like any other work that you've done before with combining like terms, variables, exponents, and all that good stuff, we only want to combine radicals if they have the same thing underneath the radical. So we are going to combine the coefficients of like radicals to simplify. In this first example here, we have 6 square root of 7, 5 square root of 7, and 3 square root of 7. Since all of these are sevens, we're going to be able to combine them together. So we take 6 plus 5, we get 11, we subtract 3, and so our final answer here is just 8 square root of 7. In this next example, we see that there are a couple of different radicals. We have the square root of 7, and then here we have the square root of 6. So we're only going to combine the ones that are alike. 5 square root of 6 minus 2 square root of 6 gives me 3 square root of 6. And then these two middle terms, 3 square root of 7 plus 4 square root of 7, gives me a 7 square root of 7. And from there, since these two radicals are not the same, then we can't combine them, and this is our final answer. Here we have a couple of other examples where you have radicals that need to be simplified first. So just like every other radical before, we're going to break down into our factors, the square root of 50 and the square root of 32. So if we break 50 up into 25 and 2, 25 breaks down into 5 and 5. So here's our pair. That's going to come to the outside. We move it to the outside and it gets multiplied by whatever was already there. So now I have 2 times 5 square root of 2. Over here, we break down our 32. So we've got 16 and 2. 16 breaks down into 4 times 4. Here's my pair of 4s. That gets multiplied on the outside. So 3 times 4 square root of 2. So that simplifies to 10 radical 2 minus 12 radical 2. Before, I was not going to be able to combine these because they were not the same radical. Now I have a radical 2 with both of them, so I can take 10 and subtract 12, and I get negative 2 square root of 2. So we're going to do the same thing down here with this next one. 27 breaks up into 9 and 3, and another 3 and 3. So we have a pair of 3s. 3 times 3 goes on the outside, so we're going to have 9 square root of 3. 48 breaks up however you want to, so maybe 16 and 3. And then 4 and 4. So we take our pair of 4s, multiply it times the 5 that's already on the outside, so we're adding 20 square root of 3. Now, since these are the same, we take 9 plus 20, and our final answer for this one is 29 square root of 3. Okay, so what I would like for you to do is take a few minutes and answer these next 3 examples. We're going to pause the video here, and then we'll come back and check your answers. So check your answers with what you have here on the screen. The first one, the square root of 6s are the only two things that combined, so we leave 6 radical 5 on its own, plus 2 times the square root of 6. When we break down the middle one, 24 and 54 actually both end up leaving a 6 underneath the radical, so we have 6 square root of 6 from the first term, and then 21 square root of 6 from the second term, and we can combine those together. So 27 radical 6 is our final answer. In the last one, we see 4 radical 2 minus 28 radical 2, which is going to give us a negative 24 radical 2. So here are some more of the same. We have 6 square root of 5 and 5 square root of 20. Again, we're going to break these down. So 20 breaks down into 5 and 4. 4 breaks down into 2 and 2 and comes to the outside. So we have 6 square root of 5 plus 5 times 2 is 10 square root of 5. And we're left with 16 square root of 5. Okay. With this next one, 18 is going to be 3 square root of 2. And then 4 square root of 2 for 32. We had that one in the last example. So we have 7 times 4 square root of 2. So we're going to have 3 radical 2 plus 28 radical 2, which is 31 radical 2. With this bottom one, right now we don't have any like radicals, so we have to break them down. 28 times this 2 becomes a 4 square root of 7. Leave the square root of 7 alone. And this last one is going to be an 18 square root of 7. And so we add together, making sure that you remember that there is a 1 on the outside over here. So we have 4 square root of 7 minus 1 square root of 7, which is 3, plus 18 square root of 7 to give us 21. Alright, so flipping our paper over, we're going to look at combining now with multiplying. And this is an example that we talked about last week with our complex numbers discussion. But we have the square root of 5 squared, square root of 7 squared, square root of 8 squared. And hopefully we are able to notice a pattern to get down here to the square root of x squared, where any number can have that same rule. So if we think about what this looks like, we've got the square root of 5 times the square root of 5, which is equal to the square root of 25, and we know that that's 5. The same thing happens if I take the square root of 7 times the square root of 7, so the square root of 49, which is just 7. And with 8, we have a similar situation. Oops, let's go back over here, sorry about that. So 64, which is going to be 8. So in this case, we see that we're left with just what's underneath the radical. So the square root and the square canceled everything out. Any number that you do that for is going to have the same result. So the square root of x squared is just going to be x. So let's apply that now to multiplying some of these radicals here. So we have the square root of 5 times the square root of 35 to start off. We are going to multiply those two things together. Okay? We can check out front for the coefficients first, but in this case we see that they're both 1s. So there's going to be a 1 out front, and we don't have to worry about writing it. And multiplying what's called the radicands, which is underneath the radical, we have the square root of 175. We want to break that down. So 175 breaks into 25 times 7, and we know that 25 is a perfect square, so we have a pair of 5s here. And then our final answer is going to be 5 times the square root of 7 when I multiply those together. In our next example, we do have numbers on the outside as coefficients, so we're going to multiply those first. 2 times 3 gives me 6, and then we have the square root of 8 times the square root of 7, so that gives me 56 underneath the radical. And here, we're going to break this up. So we can do 8 and 7. We've got 4 and 2. The 4 is going to break down to 2 and 2, so that comes to the outside. Now we have 6 times 2 outside of the radical, and then underneath we have 2 times 7 as our leftover numbers. So 12 times the square root of 14 is our final answer. You can actually work backwards with this as well, and we could have broken up this 8 to begin with. So let's look at that here. If you break up your 8, we know it breaks down into 4 and 2, and we have 2 and 2, so that 2 is going to come to the outside first. We get 4 times the square root of 2, and then we have 3 4 times 3 gives me this 12 that I got over here, and radical 2 times radical 7 gives me that radical 14. So either way works. Where it kind of defeats the purpose to break it down first is on examples like this next one. Because if you notice that you leave what's underneath the radical, we get 2 times 4, which is 8, and then 5 times 20 is 100. What's underneath the radical ends up being a perfect square, so I don't have to worry about breaking anything down. So 8 times the square root of 100 is 8 times 10, which is just going to be 80. So a couple more examples here. Square root of 6 times the square root of 20 gives me the square root of 120. And we have 120 to break down. So we can do 30 and 4, 2 and 2, 10 and 3, 5 and 2. You could have broken that down differently as well, but still ended up with the same results. 2 is going to come to the outside, and then 30 is going to have to stay underneath. So we have 2 times the square root of 30. So I'm going to pause here and give you guys a second to work these next 2 examples, and then we'll come back and check. Okay, so for our first answer, we end up with 30, because the radical 5's cancel each other out and just become 5. And our second answer, we have 60 square root of 6. Our last set of examples here show us a couple of different types of multiplication. We are distributing or we are foiling because there's multiple things for us to distribute. So we're going to multiply here. First terms, we have 2 times 5, which is 10. Our outside terms, which are 2 and the square root of 6. Our inside terms, which are 5 and the square root of 6. And then finally, we have our last terms. Square root of 6 times the square root of 6 is just going to give me 6 because those square roots cancel out. So now we can combine our like terms. 10 and 6 is 16. These 2 radicals are the same, so we have 16 plus 7 square root of 6. In this next one, we're just distributing. So 2 times 5 is 10 square root of 3. We have 2 times negative 3, which is negative 6, and then square root of 3 times the square root of 8 is the square root of 24. I want to be able to break that down first to see if I can possibly combine these. So break up your 24. This term is going to become a 12 square root of 6, and then we see that those radicals still are not the same, so we leave it just like that. I'm going to give you all a second to work this last problem, and then we will check. Okay, so notice as you FOIL, we get 2 square root of 6 with the first terms, the square root of 30 with the outside terms, 8 square root of 3 with your inside terms, and 4 square root of 15 with your last terms. We double check those, see if any of the radicals can break down. In this case they don't, and in this case there are actually not any that are the same, so we have to leave all 4 of those as separate terms. That's going to wrap up our discussion of combining radicals today. You're going to have some time to practice. If you need this video or have questions about anything and need to see it worked out further, copies of these are posted on my website for you to double check.